All right, hello, my wonderful students. This is part 4, or sorry, Foldable 4 of section 2.4 transformations, and it's dilations of f of x is equal to x squared, which is our parabola. So for this one, I already drew in your parent functions for each of them because we're just going to go through it. All right, and so we're going to go straight into it. So this first one is a vertical stretch. And if you remember, a stretch is kind of like pulling the graph this way. So this is gonna get a little thinner when we do it, and you guys will see. So the first one is -3. -3 is gonna go all the way to 18 because we're gonna multiply what we got by 2. So 9 times 2 ends up being 18, which doesn't even fit on our graph, so we're not gonna worry about it. The next one is -2, and -2 went to 4. 4 times 2 is 8, which also doesn't really fit in our graph, so we're not gonna really worry about it. Our next one is -1, and -1 times 2 is 2. So at -1, it's going to be 2 here. At 0, 0 times 2 is still 0. 1 times 2 is 2. And just to give it a little bit of, we're going to kind of like go up here. Just graph a point up there just for funsies. So 2 to 4 goes to 8. So if this was 2, 1, 2, 3, 4, 5, 6, 7, 8 would be about right here. And I'm going to do the -2 one just for funsies. Remember that we're going to cut this out anyway, so what we draw here is not really going to show, but it's just kind of a good way to show how much this is actually stretching here. So if you notice, it is not significantly thinner, but it is thinner, definitely. And if we were to show this up here, if we could show this going to 18 or this going to 9, we would definitely see a big thinness of the graph this way. So I can't really curve my hands like the parabola does. So it's like this, and now it's just a slight bit thinner. All right, so for the next one is our vertical compression. So instead of stretching the graph, we're actually gonna compress the graph on this one. So we're gonna kind of squish it. Same thing we did here. So instead of using the 16, which we couldn't graph anyways, we're going to go to the -2. And -2 actually goes to a +4. So our -2 goes to our +4, which is here. Oh, sorry. -2 goes to 4, but 1/2 times 4 goes to 2. Right there. And then our 0 still goes to 0. +2 goes to 4. 1/2 times 4 is 2. 2. And then we can see here, if we were to do the same thing again to the negative, to here, to 8, 3 would be it would be like over here somewhere. So we can see that this is actually going to go out here like this. Out here like this. So we can see how that kind of like squished together.